So here's a recap of the type of problem that we were doing yesterday, where we would have right triangles, but we don't have any right triangle where we just know a side. It would be so much easier if we knew a whole side of one of these. Okay, but we didn't, and so we'd have to go tangent of 30 is equal to TOA, opposite over adjacent. The opposite side is the x over the adjacent side is 50 plus, and I better not call it x. I hope you made up a variable for it. Okay, so I'm going to call it 50 plus y. But then, did anybody realize that since it's a 45, 45, 90, it actually will be the same as x? But it had to be that this was a 45, 45, 90. Otherwise, you wouldn't have been able to just assume that that was going to be the same as this. But in a 45, 45, 90, it is. Okay, so x is y. And so now, cool, I've got an equation that I can solve just right off the bat. Why can I just solve it? Why don't I need two equations? Because I don't have two variables. I only have one variable. Now, we kind of did have a second equation, and that second equation is the one that told us that y was equal to x. That's why we could swap it out. So we kind of did have two equations. It's just it happened so fast. Now we're down to one equation. And what was tangent of 30 equal to? TOA, opposite over adjacent of the 30. And that would be 1 over root 3 was equal to x over 50 plus x. And you're supposed to be able to solve that. Now, I know some of you didn't have me last semester. One of the things I pounded on last semester was clearing fractions. If you ever have fractions, you have to multiply by the denominators to clear them out. So if I multiply this side by the square root of 3 and this side by the square root of 3, do you get how it fixes that square root of 3 in the denominator problem? And then, if you multiply by the denominator here, 50 plus x, and over here, 50 plus x, then it'll cancel that. And now, I know that's the same as cross multiply. But cross multiply only works in very limited situations. But multiplying by the denominator works all the time. So I end up with 50 plus x is equal to x times the square root of 3. Do you see how I got it that far? Okay. Now, next part, you will never solve this until you get all the x's onto one side. So I'm going to subtract x from both sides. And then this cancels. And I've got 50 is equal to x root 3 minus x. Then, what's the key at the end of a lot of really hard pre-calc problems? If you can factor it, you should. So you go, x comes out, square root of 3 minus 1. And then you divide by square root of 3 minus 1 on both sides. And there you go. How many of you were able to pull that off solo? You got it yourself. Okay, awesome. Then you're where you're supposed to be. If not, then you're a little behind and you need to do some extra practice problems. Did you get that I didn't assign all the problems? Perfect time. If you realize, dang, I'm getting behind already, I don't get this stuff, go do some practice problems. Look at the answer keys. Okay, some of the ones we skipped before. All right. Now, just to make extra sure you're still on this, we're going to do part B together. I mean, like, we're all going to do it separately at the same time. Okay, so everybody work on part B. This time, please do not ask for advice from a friend or sitting next to you. Just try part B alone. And I'll pause for a second. Let me try to solve for x on that one. Right track. Okay. I'd move this 20 over here because then it makes a right triangle. You know what I mean? All right. And then I've got 3 triangles, but only 2 of them are right triangles. This one, not a right triangle, so I'm just going to kind of ignore it. This one, another right triangle. Got the blue one, got the red one. All right. Now, do you also get that the red one is also a 30, 60, 90 right triangle? How do you know that? Well, because I know that this plus this has to add up to 90, so that last one must be 30, right? And if it's 30 and it's a right triangle, it's got to be a 30, 60, 90. Thank you. And then this unknown side, which I'm going to call y, notice I didn't choose x because we already have an x. And I don't think that is the same size, so I definitely won't want to call it x. Now, do I have that little red right triangle? Isn't it a triangle that has one side and one angle, and therefore I can figure out anything I want? All right. Then, if you know you can find anything, which one should you find? The side that the two triangles share. All right. So what side do they share? They share this side right here. But wait a minute. I already know that side. That didn't help very much. Well, what am I supposed to find? I'm supposed to find x. Maybe I should use this red triangle to figure out how long y is. Right? And then I can use the big blue triangle to figure out what xy total is. And I can subtract. So first job, figure out y. If you haven't already, figure out y. Now there's two ways you could do it. I'm going to pull this out, and this is a good strategy for you. If you ever are getting confused by your drawing, pull out just the triangle you're focusing on and write down the dimensions that you want for it. This one's 20 on the straight side. The hypotenuse I don't know. And this one's y. And this is a 30-degree angle. If you had separated out and it's just its own little triangle, it sometimes helps. Now I'm going to go tangent of 30 is equal to y over 20. And tangent of 30, dang, I just did that a second ago. Was that 1 over root 3? I think it was. So 1 over root 3 is equal to y over 20. And then can I get y alone? Yeah, and some of you are going to say cross multiply. Nope. Notice I just need to get rid of the 20. Just multiply by 20. It's much simpler than cross multiplying. And there's my y. 20 over root 3. How many of you have got that far? Okay, good. Then I got to start looking at the big blue triangle. Now there's more than one way to do this. Somebody may have a smarter way to do this. But I'd be thinking, okay, if this is a total of 60, because it was 2 of those 30 chunks, then that must be a 30. Okay, another way to say that, some people like this, is that's a straight line. So this and this are alternate interiors. And so they have to be the same. It's another reason that that's a 30. Okay, but that's a 30 down there. So now I'm going to focus in on the bigger right triangle. And it's got a 30 here. And it's got a 20 here. 20 length instead of 30 degrees. 20 length. And then this, I know part of it. And I'm going to call it x plus root 20 over 3. Oh, sorry. 20 over root 3. Reverse those. And now, tangent of 30 is equal to 20 over, ooh, this is gross, 20 over root 3 plus x. And tangent of 30, I know, it's 1 over square root of 3. Now, because this one, I can't just like do one step and it'll be solved. I'm looking at this equation right here. I could do cross multiply and it wouldn't be such a dumb idea in this case. So I'm going to do 20 times root 3 equals this times 1. Oh, well, that times 1 is that. So 20 over root 3 plus x. Next, is x alone yet? Keep asking yourself, like, what am I trying to do? I'm trying to find what x is, right? Is x alone yet? Have I solved for x? Nope. So then I just have to do one more step and x will be alone, won't it? What do I have to do to both sides so x will be alone? Subtract 20 over root 3. Those cancel. And x is equal to 20 root 3 minus 20 over root 3. It's Kind of icky, but that's the right answer. All right. That's heavy duty stuff. But I think we've done it enough that you've probably got the idea. You write two equations, use substitution on a lot of these. Okay. And you must by now be getting the hang of SOHCAHTOA and the 306090 and the 454590. Those all have to be like happy places, like easy stuff for you. Okay, now here's a new thing. It's called bearing. And let's get to the slide on this. If you're on the same set of slides that we've been on for the last couple days, this slide right here is a pretty good one. Bearings versus true bearings. Find this one. If you were on a blank notability doc, I totally understand. Take a minute, find this slide. Yes? Good question. Would you have to simplify? It depends. If the problem asked you to simplify, you would have wanted to get a common denominator and simplify it down further. But all depends. If the test doesn't say you have to simplify, then an answer that was kind of messy, like I just had, would have been okay. All right. Then, this north, south, east, west, I know you get that. Let me just take this out for a second. Okay, you guys all know what the compass is. Okay, but imagine for a moment if you're kind of looking down on yourself right here. Which way is north? Like really? Like I know you're thinking, oh, straight forward in the classroom is north.
I know from the turf fields, the north field is the one.
Now, when they talk about the north and the south end of the building, even though, do you get that that's kind of just like that's the end of the building that is generally to the north? Do you think the building is perfectly lined up? Or the soccer fields are perfectly lined up, north, south, or east, west? There could be the northmost edge. All right, if you want to cheat and use a compass, then you could just take your cell phone out, and most of you guys have a compass on your cell phone. All right, I'm going to pause for a second while we do this. All right, so I did something in the room that you couldn't see on the video, so I'm just going to do it with a spinner here for a second. If I asked you to travel to true bearing 70 degrees, just 70, not north 70 west or west 70 north, that's totally different, just 70, then it would be here, because this would have been 90, and this is 30 off of 90, so that's where 70 would be. Here's where 90 is, here's where 180 is, here's where 270 is, here's where 360 is, same place as 0. Okay, that's called true bearings. But what does it mean when it says north 70 west? That is a different system that is allowable for navigating. So what the heck would north 70 west mean? All right. That means head north, but then adjust yourself 70 towards the west. Hold on a second. I'm going to adjust my course 70 degrees towards the west. It won't let me swing just one side. Come on. There we go. That's swinging. I'll let that swing. Okay, so 70 degrees towards the west, there. That's the direction they want you to go. What is it in true bearings? That'd be 270 plus 20 more. Very good. Because that's 70, so this must be 20. And so 270 plus 20 more is 290. Okay. Would everybody please put a little line where north 20 east would be? North 20 east. That's the next one on this little list. North 20 east. Hint, always start going in the direction they say first. So it says north, you'd start heading north, but then adjust your course. There. Okay. That would be north 20 east. Raise your hand if you did it the right way. Okay, awesome. Then what's its true bearings? just 20. Okay, how about west 45 south? That's west. You should have been going that way. Raise your hand if you had that right. Okay, good. That's west, but 45 degrees south of that. And by the way, what would we normally call that? Southwest. If you wanted to just say it, you always say the north or the south first, and then you say the other part, okay? So that's not south and it's not west, it's southwest. You've never heard it called West-South High School, have you? But have you heard of Southwest? Okay. All right. Then, how about this? East 60 north. Well, that's east. And this is 60 degrees north of that, which would be the same as what true bearing? 30. And yes, you could have said north 20 east, but it's also, wait a minute, not 20. Wait a minute. It wouldn't be north. Yeah, it's north 20. That was east 60 north would have been the same as north 30 east. Okay, what's the true bearing? The true bearing is always as simple as this. That's 0. That's 90. I bet you can tell me now. 30. Okay, good. Enough about that. Now, I hope you've got the idea there. Now, for a problem like that, there's this one called Scrappy the dog, the lost puppy problem. Okay. All right. So, just reading. Scrappy's a bad dog. First, he runs south 60 east. Is that, look close, is that the blue one or the red one?
The red one. The red one. Red.
It's the red one. Okay. Now, I want you to understand the question first, and then we'll go back and talk about how to do the problem. But so this is the little puppy, and he's running this direction. And then how far does he go in that direction? 2 kilometers. Okay, so I'm going to put a 2 there. Okay. Next, a cat diverts his path by causing him to run northwest, which is exactly between north and west, 1 kilometer. Okay, so this is a 1. Do you get that they effectively have just made a triangle for you that is not a right triangle? Now, do you get that you need right triangles still to be able to answer these questions? Then we need to either make this into a right triangle, which would work, or I'm going to show you the easier way that also will work. I know some of you are seeing it, you're going to go, I want to make that into a right triangle. But the problem is, you don't know where along the 2 kilometers that it got divided. Know what I'm saying? Okay, so that one's not so easy. I think there's an easier way. And again, the answer to this is not super easy. It's not like, oh, you just have to do this and it's easy. No, these are not easy. These are going to take you like, I don't know, 10, 15 minutes to do one of these problems. All right, so just knowing that is important to know that these are not like super easy. They're not impossible. In fact, I expect most of you will get this right on the test. It's just they're kind of tedious. They take some time. All right, this is definitely an R3 level question. Okay, so wait. You don't have any angles yet. Let me tell you how to get the angles. That's really important. Okay, do you actually have angles? Sure you do. We just don't have them labeled up here. And do we have all the angles? No. If we had all the angles, it would be super simple. But we have some of the angles. All right. So first off, this compass rose is very important. Whenever you do a problem like this, you put a compass rose, north, south, east, west. You have to put that in there. Because you're going to need to know, like, how far is that angle? How far is this angle? How far is this angle? And you wouldn't be able to make those angles unless you put in a little X, Y kind of, it's not like an X, Y axis sort of, except we call it a compass rose. Okay. So now, which angle in here do we know for sure? I'm going to give them names. Do we know A? Well, sure we do. What's that? That's a 90. That's easy. Do we know angle B? Maybe not right away. Angle C? Not right away. Angle D. Yes. What is angle D? They tell us that one. That one's 60. Okay. So put a 60 in there. Now, this is where you got to get good at remembering your geometry. And, you know, some of you were not awesome at geometry. I'm not going to say which ones, but you know who you are. And you're going to need to just trust that you are smarter than you were when you took that. At your age, you're still getting smarter every year. It's true. Not just because you're going to school. Some people think it's about coats of myelin in your brain, but I get too distracted if I tell you all about that. But anyway, so would you agree those two lines, because they're the east-west lines, those must be parallel to each other? Then we have two parallel lines and a, do you guys remember what that's called when it cuts across? Transversal, very good. That's a transversal. That's the transversal. Now, would you also agree there's two more parallel lines that read north-south on both parts? What I'm talking about? All right. Now, do you get, we can transfer that if this is 60, do you get this has to be 30 together? So angle B and C together would have to make a 30. That's one thing we know. Who could tell me something else that would be smart about the angles here? All right, I'm going to give you names for these. K, Q, R, and S. Anybody see what I did there? Famous radio station. Okay, yes?
Q and R together is 60.
Q and R together is 60. Very nice. Why? That and this. They're called something. You remember the name? Those are alternate interiors. So together, those two make 60. Even more importantly, what's K then? 30. K has to be 30. Do you get that this big triangle on the outside, I'll draw it in black here, this big triangle is a 30, 60, 90. And do you get that we have a side and an angle in that 30, 60, 90? So in that right triangle, we can know every side. Okay. That helped. Anybody else see another right triangle where we know something? You do? You just assume that there must be one because I said that. Okay, and you're right. You're right, there is one. Other side.
Wait, I think, like the second.
You think you see one?
Yeah.
Come up. Draw. Use the bright blue pen.
So,
Make it nice and thick.
right here. And you know that A and 30 has to equal 45?
A and 30 has to equal 40.
Or Q.
Q. Okay, Q and 30 has to equal 45. Help me out with this. How did you get that the A and Q have to be 45?
Which goes northwest.
Aha! So wait. Because this direction right here, remember what this arrow right here, this arrow tip is him chasing a dog at northwest. Do you get that meant this had to be a 45-degree angle and these together had to be a 45-degree angle? Northwest means exactly between north and west. All right. But the only downside is that you drew the triangle in the wrong spot. Now, it's not wrong. Harsh, rough crowd. Okay. Yeah, but absolutely that 45-degree angle there is a good call. So if that's 45, wait, doesn't that mean we know what Q is also? Aha. Now we know a side and an angle of where? Of what? All right. I know. There's triangles everywhere. All right. So now try to remember that we had 45, 15, and 30 figured out there. Okay? Because we're going back in time. Okay. I hear you, but I got to focus on you guys in class right now. So, all right. Did we figure out that this was 45 right here? You remember that? And this was 15? And this was 30? All right. Now I'm going to draw you the 3 key right triangles that you need to know to be able to answer this question. We already talked about this one. That to there. I got to move that up a little bit. Just patient here. And then to here. Oh, no. Pink. And then there. That. Notice it's on the outside of the triangle that Scrappy made. See, it's on the outside of that triangle. Here's the next right triangle that we need. I went too far. I'm going to try again. Do you get that that makes a right triangle that's right along our Scrappy triangle? And last but not least, this is going to make a right triangle. I'm just struggling with whether I should go up here far enough to make this the right angle, or whether I should make it... I think I should do it like that. Yeah. All right. So now, fundamentally, I just made right triangles on the outside of the triangle that I had. Think about it. Doesn't a triangle have 3 sides? Therefore, all 3 of those sides could make their own right triangles. Okay, so that's what we did. And now we're going to give them names. All right. That is north, total distance heading north or south. I could have said south. Do you agree that it's made up of north 1 and north 2? Do you get that those 2 sides, this side and this side, have to equal that side? And do you remember that we could have gotten this triangle right here because we had one side and one angle, 2 kilometers long here, 30 degrees, and therefore I know north total. You get what I'm saying? Do you get that you can know this number? You can know that number. We can find that number. It's easy. There's a little trig and you'll know that number. But this number and this number add up to that. Why does that matter? Because we'll be able to, therefore, figure out either one of these 2. And which one do you think will be easier to figure out, north 1 or north 2? North 2. Once I have north 2, because this is a 45, 45, 90 right here, do you get north 2 isn't going to be too hard because the 2 sides will be the same and that one won't be too tough? Once I know north 2, north 1 will be obvious. If this had been like, 1.5, then, and I figure out this is 1, well, and the other one would have to be 0.5. They're not hard to do once you know that north 1, north 2, and north total all add up to each other. All right, then, do you get that this is, I should probably say east total because I was going like, I'm going to call that east total. Do you get there's 2 sides that make up that one? This little side, east 1, and east 2 would add up to east total. And can't I know east total? Yeah, it's on one of the triangles that I know, a side and an angle. So I can know north total and I can know east total. What's critical is that you be able to draw around the outside of these. All right, so that is your challenge for tonight's homework. So when you have, we're down to 12 minutes left, your homework for tonight is going to be not this problem. We're going to do a few where the answer key has the answers for you. This one's in the notes, and therefore there isn't like worked out solutions to it. But I'm going to give you a couple like that to do. You're going to have to go around the outside. So just quick, do you get if I draw any triangle? Then I can make right triangles out of the sides. See what I'm saying? Kind of missed on the last one. And then if I call this north total, it would have been made up of north 1 and north 2. Does that make sense? And do you get you're always going to have north, south, east, and west in your problems? Because they're bearing problems. And this can be east total. And do you get it would be made up of east 1 and east 2 from here to here? That make sense? Okay. That's the big picture. That's how you do this kind. You're still going to have right triangles. You're still going to have 2 unknowns. So you got to get at least 2 equations with 2 unknowns, and you'll be able to solve it. All right, so let's find a problem like that in day 2's homework right here. There's no picture. You're right. You make the picture. Now, I'll help you get this one started, but all right. And it's got this weird angle in it. And I'm going to show you how to use your calculator. The good part is you aren't going to have to do all of this in your head. You'll be able to use the calculator, right? So what on earth does 68 degrees 22 minutes mean? 68 degrees plus, you might want to write this one down, plus a fraction of a degree, right? And some of you remember what I said about this. What would it be again? 22/60th. Very good. 68 plus 22/60th. It's going to be a decimal. That's how many degrees that is. All right, now do you kind of know where 68 degrees is? All right. So it's heading northwest. So I'm going to start my drawing so that when I head northwest, which is kind of that way, it's kind of northwest. Okay. I'm going to start my drawing down here. And they have a ship down there that it was supposed to be a little clue that it starts down there. So everybody make a dot down there. That's where we're going to start from. And we're going to head northwest. Well, northwest is an exact direction. It's really nice, actually, because it's going to make a 45, 45, 90, you know what I mean? Because northwest, when I go this way from my compass rose, I just created 2 45-degree angles, which is real nice. Now, wherever you stop, make another compass rose there. So let's say that he stops right there, and he's going to change directions right there. Compass rose. And now, right away, I know 2 angles up there, too. Know what I mean? If this was traveling at a 45-degree angle, then it comes in at a 45-degree angle. So this is a 45, and that's a 45. Okay, now where is he going from there? Oh, wait, and he said it went 16 miles. I'm going to write that on here. And let's not put the M. It just clutters it up. We'll know our answers in miles. 16 miles. Technically, to put an MI, otherwise it looks like meters. Oh, and it's kilometers. You're right. We would put a little K, but it's just going to mess up the drawing, so we're just going to leave it as a 16. All right. And now it heads in a direction of north 6822 west. So I'm heading north, but I'm swinging this, which is a 68 point something. Has anybody got it already? All right. Pausing. So it's 68.37 degrees. And that's swinging towards the west. So this is the west, right? So it's swinging about 70 degrees west. Do you have to draw a drawing perfect? Of course not. But that should definitely be more like 70 than it is like 40, okay? And exactly how big is that angle? I'll write it in there. 68 point, let's call it 0.4 degrees. And now that I know that's 68.4, do you get I know this angle too? Because they together have to make 90? Okay. Now, it goes 22 miles. Oh, I should extend this a lot further. Now it says, find the ship's distance and bearing from Old Port. Well, here's Old Port where we started. And so I'm going to make this a bright pink line. That is what they want to know. Do you see we've got a not right triangle? Can you picture drawing in the right triangles that go around it? Like that one. Come on, computer. Like that one. And this one. And this one. And this one I'm going to do in bright blue. That one's going to be an easy one to figure out. Know why? We got a side and an angle, and it's a 45, 45, 90. So we'll instantly get two sides. See on the bright blue one? See how easy this is going to be? Because we got one side and an angle, and it's a 45, 45, 90. And then last but not least, I'm going to call this east total. Do you get it's made up of this line here? I'm going to call it east 1. And this line here, east 2. And if I just figure out east 2 and east 1, I could find east total. Or maybe I'll be able to figure out east total first, and then I'm definitely going to be able to figure out east 2. And then I can figure out what east 1 has to be. All right, so there's a lot of help on setting that one up. You might feel like these are impossible right now. They're really not. You're going to have 3 right triangles, all of which will work. And then it's about writing 2 equations, solving. All right, and then I want you to do one more lamp post question. This one's got a better drawing than that other one did, so it might be a little easier. When they say the shadow, remember these are the shadows. That's a shadow from one position of the sun. And then the longer shadow would be from here to here. That's the other shadow from the other position of the sun. And make sure you label in all the things you know. Okay? This one's the one that's higher in the sky, and so it's the one that's 74 degrees sun. When it falls to 62, do you get when the sun goes lower in the sky, you get a longer shadow? That make sense to you? All right, so there's some help on setting these up. You got to do your part. If I'm helping out like this, instead of just saying, there, go for it, you need to really dig in and finish these problems. I would get, if I didn't give you that help, it might have felt impossible. But with that help, you should be able to do these. All right. And one more, this one. I know That may feel like a lot, but I know that you have a test next week. And I want to make sure that you're ready for it. So, aiming towards Friday, actually. That was a good guess. I was originally leaning towards Thursday. You might have seen that in my notes, but because we're going to do something more fluffy on Monday, that'll probably push it to Friday. So you don't have to be an expert on this yet. You get to have a whole nother week to be totally good at this. But if you take this weekend off, you come back and be really confused on Monday. All right, get your homework done. That's all I got for you for today.